Whether you're a farmer planting crops or a student walking on Central Campus, soil and weather are very important in people's lives, which is why NASA has launched a new program to understand our soil better. Called Soil Moisture Active Passive, or SMAP, the 3-year program's mission is to get data on the world's soil moisture. The data will be collected by using a satellite orbiting between the poles. It has a reflector that will reflect light down to the Earth's surface, which will bounce back to the satellite, collecting data. SMAP member and Iowa State professor Brian Hornbuckle explains.
So you can imagine this radiation is coming up through the soil and it hits the soil surface, and whenever radiation hits the boundary between two materials that have different electrical properties, some of the radiation gets reflected and some gets transmitted. And when the soil is very dry, a lot of the radiation gets transmitted and we see a lot of radiation from space. Earth looks really bright. Okay? But as the soil gets wetter, more and more of this radiation gets reflected back into the ground, less gets transmitted, and Earth looks dark or cold.
Soil moisture might not sound very important, but Hornbuckle says SMAP can help improve lives in different ways.
5 main impacts of soil moisture from SMAP. Better short-term forecasts, better long-term or seasonal forecasts, keeping track of water in the soil, better predictions of flooding, better estimates of how much soil is being eroded.
This is done by analyzing the wide variety of data collected, including how much water is in the soil before and after storms, which would improve weather forecasting.
Soil moisture is really important in telling us how water moves between Earth's surface and atmosphere.
This is being recorded for the first time and will allow meteorologists a better view of short-term weather. Hornbuckle has worked on similar projects measuring soil moisture, such as the European Space Agency's SMAP satellite. But SMAP is special.
SMAP is different in the sense that it adds another instrument. SMAP is combining both the camera and the radar together, and the result will be better, what we call spatial resolution and measurements.
The National Weather Service uses soil moisture data when issuing flash flood warnings. Because of this improved resolution, the service can now predict floods better. SMAP will change our view of soil and agriculture, but it is just a stepping stone for things to come.
SMAP is one step in the direction of allowing people to make better decisions about what they're going to do, which will have impacts not only on them but also on our greater environment. And we need to be thinking carefully about how we manage our home planet, because it's the only one we got right now.
For ISU TV, I'm Will Dodds.